Finally, we have come to the end of this chapter. Before we summarize it, let's try some past year examination questions. You may pause the video and try the question before the discussion for the solution. Question 1. Functions f and g are defined for x is an element of real number by function f such that x is converted into 3x minus 2 and function g such that x is converted into 7x minus a over x plus 1, where x is not equal to 1 and a is a positive constant. Function f of x is equal to 3x minus 2 and function g of x is equal to 7x minus a over x plus 1. A. Obtain the expression for f inverse and g inverse. We let the inverse function of f equal to y. X equal to fy. Substitute y into the function f, we have 3y minus 2. Then we make y the subject. Y equal to x plus 2 over 3. And finally, we have f inverse of x is equal to x plus 2 over 3. Here we have another function, f inverse. To find the inverse function of g, we let g inverse of x equal to z. X equal to g of z. We substitute z into the function g. We have 7z minus a over z plus 1. Multiply both sides with z plus 1. Then we expand the bracket. So we got xz plus x equal to 7z minus a. Collect all the terms with z at one side. I would like to have a positive x and positive a, so I'm going to move the xz to the right side. X plus a, 7z minus xz. Then factorize out the z. And lastly, divide both sides with 7 minus x. We get z equal to x plus a over 7 minus x. Substitute z equal to g inverse of x. We get the function for g inverse. Here we have g inverse is equal to x plus a over 7 minus x. B. Determine the value of a for which f inverse of g4 is equal to 2. Seems like we are going to use the function f inverse g only once in this question. I'm not going to find a general function for f inverse g, but instead I'm going to find the value of g4, then substitute into f inverse. G of 4 is equal to 7 times 4 minus a over 4 plus 1. We have 28 minus a over 5. F inverse of G4 is equal to 2, which means F inverse of 28 minus a over 5 is equal to 2. Substitute 28 minus a over 5 into the inverse function of f that we already found in part A. 28 minus a over 5 plus 2 over 3 is equal to 2. Our purpose here is to find the value for a. Therefore, we multiply both sides with 3 and then minus 2. We get 28 minus a over 5 is equal to 2 multiplied with 3 minus 2, which is 6 minus 2, we get a 4. Then we multiply both sides with 5. 28 minus a equal to 4 times 5, which is 20. Therefore, a is equal to 28 minus 20, and we get a 8. C. If a equal to 9, show that there is only one value for x for which g of x is equal to g inverse of x. G of x is equal to g inverse of x, and our a is equal to 9. For gx, we have 7x minus 9 over x plus 1 is equal to g inverse x plus 9 over 7 minus x. We do cross multiplication. Hence, we have 7x minus 9 multiplied with 7 minus x is equal to x plus 9 multiplied with x plus 1. Then we expand the bracket. Do it for both sides. We have 49x minus 7x squared minus 63 plus 9x equal to x squared plus x plus 9x plus 9. Simplify the equation. We have 58x minus 7x squared minus 63 equal to x squared plus 10x plus 9. In order to get a positive value for x squared, I'm going to move all the terms to the right side. Hence, we have x squared plus 7x squared plus 10x minus 58x plus 9 plus 63 equal to 0. Simplified again, we have 8x squared minus 48x plus 72 equal to 0. Divide the whole equation with 8, we got x squared minus 6x plus 9 equal to 0. So we need to show that there's only one value of x for this condition. In order to do that, we need to find the discriminant b squared minus 4ac. Here, our a is equal to 1, b is equal to negative 6, and c is equal to 9. B squared is negative 6 squared minus 4 times 1 times 9. We have 36 minus 36, which is 0. Since b squared minus 4ac, our determinant is equal to 0, there's only one solution for x. Question 2a. Sketch the graph of y equal to modulus 3 plus 5x, showing the coordinates of the point where your graph meets the coordinate axis. In order to sketch the graph for a modulus function, first we sketch the graph without the modulus. Let y equal to 3 plus 5x. When x equal to 0, y equal to 3 plus 5 times a 0, which is 3. When y equal to 0, 0 equal to 3 plus 5x, 5x equal to negative 3, x equal to negative 3 over 5. This is the y-intercept, and this is the x-intercept. If we put all the value into a table, we will get a table that looks like this. Negative 3 over 5, 0, 0, 3. Then we sketch the graph. We draw two axes, x-axis and y-axis. When x is negative 3 over 5, y equal to 0, somewhere here, negative 3 over 5, 0, and 0, 3. This is how the graph should look like without the modulus. Because we have a modulus graph, all the negative part will become positive. So we get a graph that looks like this instead. So y equal to modulus 3 plus 5x. B. Solve the equation modulus 3 plus 5x equal to 2. First, we separate the equation into two parts. The first part is 3 plus 5x equal to positive 2. And the second one is 3 plus 5x equal to negative 2. Then we solve for the x value one by one. For the first equation, we have 5x equal to 2 minus 3, which is negative 1. Divide both sides with 5, we get x equal to negative 1 over 5. For the second equation, we have 5x equal to negative 2 minus 3, which is negative 5. Then we divide both sides with 5. Negative 5 divided by 5, we get negative 1. You can check the answer from the graph that we sketched just now. This is the value, y equal to 2. If we draw a horizontal line, we can see that the intersection point is at here and here. And both value is a negative x. Question 3. The function f is defined by f of x is equal to 2 minus square root x plus 5 for x between negative 5 and 0. A. Write down the range of f. We have x is greater or equal to negative 5 and lesser than 0. If we add a 5 to the x, we have negative 5 plus 5, and over here we have 0 plus 5. Square root x plus 5, we have square root 0 and square root 5. If we multiply the whole thing with a negative, we will get 0 greater or equal to negative square root x plus 5 greater than negative square root 5. We rearrange the whole thing. We have negative 5 is lesser than negative square root x plus 5 lesser equal to 0. Then we add a 2 for the whole inequality. We have 2 minus square root 5 lesser than 2 minus square root x plus 5 lesser equal to 2. Replace this by fx. We get the range for fx, which is fx is greater than 2 minus square root 5 and lesser equal to 2. B. Find f inverse and state the domain and range. We let the inverse function of f equal to y, x equal to fy. Substitute y into the function f. We have 2 minus square root y plus 5. Make y the subject. Square root y plus 5 equal to 2 minus x. Square both sides. and then minus 5. Therefore, inverse function of f is equal to 2 minus x squared minus 5. State the domain and range. For fx, this is the domain, and this is the range. The domain for fx will become the range for f inverse, while the range for f will be the domain for f inverse. Therefore, we have domain for x is between 2 minus square root 5 and 2. And for the range, f inverse x is greater or equal to negative 5 and less than 0. The function g is defined by g of x is equal to 4 over x. For x is greater or equal to negative 5 and x is less than negative 1. Solve f of gx equal to 0. Firstly, we need to find the composite function for f gx. Substitute gx into the function f, we have 2 minus square root gx plus 5. Substitute gx again, 2 minus square root 4 over x plus 5. And let it be 0. So 2 minus square root 4 over x plus 5 equal to 0. 2 equal to square root 4 over x plus 5. Square both sides. 4 equal to 4 over x plus 5. 4 over x equal to 4 minus 5, which is negative 1. And then we have x equal to 4 divided by negative 1, which is negative 4. Question 4. The diagram above shows a function f maps set A to set B, and the function g maps set B to set C. Find, in terms of x, the function which maps set B to set A. We need to find the function that maps set B to set A, and it is actually f inverse. Here we have fx equal to 4x plus 1. A, we let f inverse of x equal to y, x equal to fy. Substitute y into the function f, we have 4y plus 1. Make y the subject, y equal to x minus 1 over 4. So therefore, f inverse of x is equal to x minus 1 over 4. A2. In terms of x, find the function of g of x. Function g maps set B to set C. So basically we have g of 4x plus 1 equal to 12x plus 5. We have g of 4x plus 1 equal to 12x plus 5. We let 4x plus 1 equal to w. Then we make x the subject. We have 4x equal to w minus 1. X equal to w minus 1 over 4. We need to use this piece of information later on. We substitute 4x plus 1 with w. We get g of w equal to 12. Substitute the x with w minus 1 over 4 plus 5. Why we do so? Because we already changed the object to w, hence we also need to change the function into w. Then we simplify it and expand it at the same time. We have 3w minus 3 plus 5, which is 3w plus 2. Therefore, gx is equal to 3x plus 2. B. Find the value of x such that f of gx equal to 8x plus 1. F of gx is equal to 8x plus 1. Let's find the composite function for fg and solve the question at the same time. Function f is 4x plus 1. We have 4gx plus 1 equal to 8x plus 1. The function gx we already obtained in A2, and we substitute it, we get 4 multiplied with 3x plus 2 plus 1 equal to 8x plus 1. We expand the bracket. 12x plus 8 plus 1 equal to 8x plus 1. Here we need to solve for the value x. 12x minus 8x is equal to 1 minus 9. 4x equal to negative 8. X equal to negative 8 divided by 4. X is equal to negative 2. Last question, question 5. It is given that function f such that x is converted into 2x minus 3 and function g such that x is converted into 1 minus 3x. A. Find g of 5. Here we have fx is equal to 2x minus 3 and also gx is equal to 1 minus 3x. A1, we need to find g5. We substitute 5 into function g. We have 1 minus 3 times 5. 1 minus 15, negative 14. A2. Find the value of m if f of m plus 2 is equal to 1 over 7 g of 5. F of m plus 2 is equal to 1 over 7 g of 5. We substitute m plus 2 as the object into the function f. We have to multiply with m plus 2 minus 3 equal to 1 over 7. G of 5, we already obtained the value in A1, which is negative 14. We need to solve for the value m, hence we do not need to expand the bracket. 2m plus 2 is equal to negative 7 plus 3, which is negative 4. Divide both sides with 2, m plus 2 equal to negative 2. M is equal to negative 2 minus 2, which is negative 4. A3. Find g of fx. G of fx. Substitute fx into the function g. We get 1 minus 3 fx. Substitute the fx again. Then we expand the bracket. 1 minus 6x. Negative and negative, we get a positive 9. Simplify it, we get 10 minus 6x. B. Hence, sketch the graph of y equal to modulus g f x for x is between negative 1 and 3. State the range of y. We have g f x is equal to 10 minus 6x. Y equals to modulus g f x, which is modulus 10 minus 6x. X is between -1 and 3. First, we draw the graph of y without the modulus. Prepare a table to get the value for x and y. The smallest is -1, greatest is a 3, and we also need to find the intercept. When x is -1, 10 plus 6, 16. When x is a 0, y equal to 10. When x equal to 3, 10 minus 18, we get -8. We find an extra information. When y equal to 0, what is our x value? 0 equal to 10 minus 6x. 6x is equal to 10. X equal to 10 divided by 6, which is 5/3, which is 1.6. First, we draw the axis. X and y. We have -1, 1, 2, 3. When x equal to -1, we have 16. So the greatest value is 16. This is 8. This will be -8. -1, 16. 0, 10. 10 is somewhere over here. And 3, we have -8. So this is how the graph looks like for y equal to 10 minus 6x without the modulus. If we have a modulus, all the negative value will become a positive. 3 -8 will become 3, 8. For this part, it will flip, and this part will remain. And this point is actually 1.6. And this is a 10. Y equal to modulus of g fx. We are asked to state the range of y as well. So the greatest value is a 16 and the smallest value is a 0 when the domain is between -1 and 3. We have y is between 0 and 16. That's all for this chapter, function. In the next video, we will start a new chapter. So see you again in the next video.